Hi, in the previous class, we discussed about a simple DayTime client program and basically written on the client side to take or collect the data. What data? It's about the date and the time. A simple C program which collects the date and time from the server, or in other words, another machine. So how do I write a C program to connect to another machine and get the data, read the data from that machine and display it on the client? So that was the program that we had discussed in the previous class. So in this program, we understood what all are the various steps. So we include the required network programming headers through a common user-defined header file that was unp.h. That is, in short, it is actually it is Unix programming.h. So unp.h, and then we also understood that to connect to another machine, I need to pass the IP address. So to which machine I need to connect. So this IP address, I'll be passing it through the command line argument. So this command line arguments, as you all know, it has to be passed along with when I execute the program. So I will be using the command line arguments, and we have seen how to write a socket, how to call the socket function to establish the connection between two machines. And then we have seen the server and the server's IP address and the port are clubbed together to form one socket, and what is that the socket is going to contain and how it is going to establish connection. So we have seen how IP address gets recognized by the machine using H2NS or P2N, that is host to network functions, and presentation to network functions. So these are the two functions which we'll discuss in detail in the later sessions. So basically this is also another functionality of creating a socket, and we have also seen what is the server address family that or in other words it is protocol, the protocol which we are using for the communication, the type of communication. We say it is AF INET, so that is mentioned here. And so okay, let me point it at this. So it is AF INET, that is the family. Basically it refers to the TCP protocol or TCP kind of streaming of data. So what are the different types? All that we'll study later. So next is the next functionality, important functionality in this is establishing connection. So how do I establish? Once I know the server IP address, once I know the port number, then how to establish connection with the server, and that is done by calling the connect function. And then we read the data from the server, that is whatever IP address I am passing, that IP address belongs to another machine, I call it as server, and I am going to collect the date and time from that server machine. So when I receive the data, how do I read it and how do I store it? That is also another important function. So I read it using the loop, so which I have mentioned here in this third block. So while I have already discussed in detail why we are using this while loop in the previous class. So we read the data, and then once I get all the data from the server, I'm going to display it on the client machine. So these are the major functionalities of a simple, program that is basically used for connecting two machines and exchange of data. Okay, so in this program, we are talking only about the request that is sent from the client, and from the server, the date and time is being sent back as a response. Okay, so this one is a very simple program, and you need not worry about all the syntax of this right now, because we are going to dig more and more with the same program in the later sessions, so that once you get to know what a program, what a network communication, or whenever I want to write a network program or a program on a network, then what all are the major functionalities. Just to understand that, I'm giving you this example. So later on we'll discuss more on the syntax part, the parameters, how to use all these functions, when to use the functions, what all are the families, what protocols must be used. All that we will study in detail in the later sessions. So this program is just basically to give you an idea about how to write a network program. Moving on, uh, when I execute this program, how do I execute this program and what will be the output of this program? So this is a simple screenshot that I am showing you. So if you see, there is the dollar prompt. So it means this basically this program is running on a Unix or a Linux platform. Basically, this program was actually, the demonstration was done on a Solaris system, which is given in the textbook. But when I run this on the Unix program, we see this dollar prompt, and when I compile, I'm giving the name as a.out. I hope you all know how to compile and execute a program, C program in on a Unix platform or a GCC platform. So I need not talk much about what is a.out. So when I execute the program, you all know that I'm going to use the command line arguments. So this is my first command line argument. So this is the file that I'm going to execute, that is a.out, and then I'm passing a parameter, and that parameter is the IP address. So all of you know what kind of an what is the format of an IP address. So I'm just passing this IP address. It means my machine or my client system is going to talk to this particular server. So this 206.168.112.96, this is the IP address of another machine, or in other words, I would like to say it is a server's IP address. So this server's IP address becomes the destination, or the server machine's address to which my client is going to talk to. Okay, so this is a parameter which is passed to this program a.out during execution. So that becomes our input, and whatever is written in the red color, that is the output that we get. So output is displayed as Monday, May 26, 2020. That is 20. This is the time. This is the date and week, month, date, and time and year. So this is the sample output that we are getting from the server as the response. So this is the program output, and this is a very simple program. So when I run this program with a particular IP address, then the request is sent to this particular IP address, and I'm going to receive the date and time from that particular machine. Whatever is the date and time that is running on that machine, that will be sent back as the response. Okay, so this was a simple program and its execution part. Then so that was about now here when you see, I'm passing the address, IP address, and it is in which format? It is in IPv4 address format. So we see the octets here. We see the 4 octets. So 206 is an octet, 168 is an octet. So it means it is a octet means 8 bits. So 8 bits represent one number. So that is, so there are 4 8-bit numbers. So it is a set of 4 octets. Okay, so when these 4 octets represent an IPv4 address, an older version. So what happens if I want to send a request to a server, but the server IP address has IPv6 version? Then my whole entire program doesn't work, it doesn't support. So what we do here is, I will just go back to the same program and I'll just make some changes here. So only I'm highlighting those lines of code wherein I'm going to make the changes. Rest of the entire program remains same. No other change in any part of the program, only in 5 different lines I will show you, and it has been highlighted here. So here you can see sock address IN6. So this is the change which is been highlighted in bold. Earlier in the previous program, it was sock addr underscore IN. That's all. Now if the server is having an IPv6 address, then I have to make small changes in front of IN. I'll just suffix 6 in front of it. So this will tell my client program that the server is having an IPv6 address. And then moving on, the another change in the program is in line number 10. So here you can see if underscore inet6. So here I am using another macro. So previously it was af underscore inet, and now I am using af underscore inet6, representing the TCP family, which is going to deal, or which is going to transfer data through across IPv6 addresses. And then in the next change will be here in line number 13. In line number 13 you can see sign 6 underscore family equal to af underscore inet6, and then in line number 14 it is sign 6 underscore port, and again in line number 15 it is af underscore inet6, and here server address dot sin6 underscore address. So this is server internet address. So server internet 6 underscore address. So wherever I am using these AFINet or SYN address or SYN port, wherever I am using this, that all these must be changed to SYN6 underscore family or AF underscore INET6. So these are the only changes that we are going to do in this program. So what is after making these changes, again when I execute the program, it is the same execution that we will see. I'll again get back the date and time from the server, but the server IP address is in IPv6 format. That is what. So if I want to deal with the machine, or if I want to communicate with the machine which is running on which is using an IPv6 address, then these are the changes that we are going to make. Now, what is the advantage or disadvantage here? What we are going to see here is the majorly, if the server is IPv6 address, then this program will run. If the server is using IPv4 address, then my previous program would suffice. But do I know what is the IP address of the server? If I don't know what is the IP address of the server, then this program becomes protocol dependent. Correct? So the protocol which I am using, whether I am using SYN6 or just SYN, AFINet or AFINet6. So this dilemma remains if I don't know what is the IP address of the server. So in the first program, it was dependent on the protocol and it works only on IPv4 address. And the second program, when I modified it, it works only on IPv6 servers and or IPv6 IP addresses, but it does not support IPv4 machine. So is there any program wherein I can write one generic program which supports both IPv4 and IPv6? Of course, yes. And these are nothing but the advancements that we see. So in the later session, we will see how I can write one generic program which supports both IPv4 and IPv6 formats. Okay, so and that is done by using another function which I have mentioned here, just for you to remember, get address info method. This is one special function which we are going to use to write a generic program later. Okay, so moving on, so there are we have something called as wrapper functions. So basically wrapper functions means there is a function which is already predefined, and I'm going to write another function which calls these predefined functions. Okay, so what is the purpose of that, and what is the necessity of creating another function calling a predefined function? So as you see in this particular program, I want to give you an example. If I want to, if there are multiple types of inbuilt functions and all of them are doing a similar kind of job, then I want to make them specific to a certain kind of functionality. Okay, in that case, I wrap those functions in a user-defined function name. So I'll just give you a brief on that. So in the previous two programs, we have seen connect function, read function, socket function. These are all the inbuilt functions that we are using. So since terminating on an error is a common case, so it can be socket while connecting to another machine using socket, there might be a problem, technical issues or something. So some kind of error message would be generated, and this can be a very common case. Okay, so we can shorten our programs by defining a wrapper function that performs the actual function call. So whatever is the error, I'm going to call the error function, but I want to give a graceful exit of the program. I don't want to display some system error messages on the screen which the user don't understand. So to have a graceful termination from the execution of the program in case of error, we make use of these wrapper functions, and these wrapper functions will be specific to different types of errors. So so we call this as wrapper functions. So these errors can be due to whenever there is an actual function call, the test can return a value and terminates on an error. So the convention we use is to capitalize the name of the function. So syntactically, how do I differentiate between an inbuilt function and a wrapper function? So inbuilt function, most of the inbuilt functions in C, they are all in small case. Okay, whereas a wrapper function, the name of the function remains same, but the first letter of the function will be capitalized just to distinguish between an inbuilt function and a wrapper function. So in this example, you can see here, this is the socket function. As you see, socket function with the capital letter S. So whenever I come across a function with the capital letter in the first letter being capital, then we should understand that it is a wrapper function. It means there is another function which is being called inside this, and that is a predefined function or an inbuilt function. So here you can see socket function which is predefined, and this is called by socket function, that is a wrapper function. Okay, so this one is a simple example for you to understand what is a wrapper function and why do we use the concept of wrapper function. Then moving on, we will this is a part of assignment for you. I just want you to go through the text, whatever has been mentioned, referred, the textbook that is being referred at the beginning in the introduction. I want you to go through the chapter 1, so from section 1.1 to 1.4, that talks in detail about this particular program, a simple DayTime client program. So with this, I just want to end the session, and we will continue in the next session with many more concepts of network programming, and we'll get deeper into what all are the advancements and how to write simple programs, what are the families and protocols that we use in our network programming. Thank you.